Next, let us look at the work example given by the Arahant technique, demonstrating the applications of the equations as well as the working steps to design the thickness of the rod layers. The relevant informations are given here. The daily traffic volume ADT in both directions is equals to 6,600. The percentage of the commercial vehicle PC is 15%. The annual growth rate 7%. Equivalence factors 2.0. Subrate CBR 5%. And rolling T-rank. Now that the ADT is given, which is 6,600, PC is also given 15%. We will need to calculate the initial annual commercial traffic in one direction, which is V0. Use these equations. The information's ADT provided is the daily traffic, as we need to calculate the annual commercial vehicles. It should be multiplied with 365 days per year. The ADT provided is in both directions. Since we are quantifying in one single direction, ADT is to be multiplied with 0.5. We are determining the annual commercial traffic V0. That means out of the ADT here, multiply with the percentage of the commercial vehicles, we are getting the V0. Substitute 606,000, 15% into the equations. We get 180,000 vehicles per year. Next step, we need to determine the total number of commercial vehicles in one direction at the end of the design period. This will require the growth rate of the traffic based on the initial annual commercial traffic volume, taking into the growth rate as well as the design period of 10 years. We get 2.5 million vehicles per year in one direction. You will observe a significant growth in terms of the number of vehicles in 10 years, with the 7% growth rate. In this case, we assume the V0 here, which is the initial annual commercial traffic, represent the initial passing of the traffic when the road is first utilized. Therefore, the total durations for the X here, it will be considered as the design period, instead of having the construction period being added into. Our next step, it will be calculating the ESA, equivalent standard SL. Use the VC that we calculated just now, which is 2.5 mils of vehicles per year, multiply with an equivalent factor E. Now, in the absence of an actual load survey, you may refer to this table in order to determine the E. The equivalent factors is given in the work example. Let's say now we acquire the equivalent factors from the table here. It is given that the percentage of commercial vehicles is 15%. You may look for the appropriate range, assuming it is a trunk road. Then the equivalent factors is equal to 2.0. Trunk road refers to the important main road for long distance travel. As for the local road, it is referring to the street road, giving access to residential, commercial units. Substitute VC and also 2.0 of EC into the equations. You get ESA somewhere between 5 mil. Next, you will need to work out the equivalent thickness using the monograph. In order to use the monograph, you need ESA and also the CBR. The CBR is given, which is 5%. And we shall look into the monograph to get the corrected equivalent thickness. Based on the description here, we know the process of using the monograph. We start with 3% CBR, passing through a point of 5 million ESA as calculated here, which is between 10 power of 6 to 10 power of 7. Draw a straight line passing through the 5 million ESA, and it will meet at the TA here, which is around 29. The equivalent thickness of 29 is on the basis of 3% CBR. For 5% CBR, which is other than 3% CBR, you will need to draw another line passing through this 29 TA. Draw a straight line from 5% CBR passing through the 29 TA. You get a new TA known as the corrected equivalent thickness, TA prime. TA prime now is 26. With that, you will use these equations to determine the thickness of different layers of rods. We have wearing cost, binder cost, base cost, and sub-base cost. Each layers of rod has their own structural coefficients, which you can get it from the table here. The structural coefficients is governed by the type and the properties of the rod layers. You will need to first determine the layer coefficients. Let's say now in this case, we'll use Ausfed concrete as the wearing cost and the binder cost. Referring to the table here, the coefficient shall be equals to 1.0. As for the base cost, mechanically stabilized crush aggregate is used. Referring to the table here, the coefficient is 0.32. As for the sub-base cost, sand or laterite is being used. Refers to the table here, sand and laterite 0.23 coefficients. With that, the coefficients are determined. Next, you will need to propose the thickness of each rod layers. You may refer to the minimum layer thickness as a guide, as well as the standard construction's layer thickness. According to this table, let's say we are referring to the standard thickness. The wearing cost should range between 4 to 5 cm. That sets the minimum and the maximum thickness of the wearing cost. The binder cost between 5 to 10 cm. That sets the minimum and the maximum thickness of the binder cost. Assuming the base cost is wet mix and the subgrade cost is granular, we will acquire the standard thickness of the wet mix 10 to 20 cm and granular 10 to 30 cm. That gives you the proposed range for different types of rod layers. Check those values against the minimum layer thickness. 4 cm, 5 cm, 10 cm, and 10 cm. This is well in line with the standard thickness. Now you may propose the thickness for different rod layers. Make sure the proposed thickness fall within the range of minimum and maximum thickness. If it is going beyond the thickness or less than the proposed thickness, the pavement is considered to fail. Now that you have acquired the structural coefficients for different layers of road pavement, as well as the proposed thickness, use these equations to generate the TA, equivalent thickness. This is calculated by multiplying the coefficients with the proposed thickness plus multiply coefficients with the proposed thickness plus coefficients multiply proposed thickness and coefficients multiply with proposed thickness. The summations of all should be greater than 26, which is the TA prime required. The 26 TA was determined from the monograph. There is one more requirement that you need to check, which is the minimum thickness of bituminous layer. Based on the TA that we have acquired, which is 26 cm, you will need to find the range to determine the total thickness of bituminous layer. TA 26 fall within the range of 23 to 29.5 cm. You will need at least 15 cm bituminous layer. Coming back from the proposed thickness here, the wearing cost and the binder cost are asphalt concrete. That gives 15 cm, which meets the requirements of the minimum thickness of bituminous layer. Asphalt concrete is made of bituminous as the binder to the cost. Now, in the case that the base cost is also made of bituminous, that will give you different range for the maximum and minimum thickness. And then when you calculate the bituminous layers, it will be the summations of all three: wearing cost, binder cost, and base cost, since they are all made of bituminous layers. In this case, the proposed bituminous layers is 35, which is more than the minimum of 15. Coming back to the wet mix, the proposed is 15 cm versus the minimum requirement of 15 cm. That means the proposed thickness of the root is suitable. With that, this completes the part of designing the thickness of the road layers. The Arahan technique also provides equations to check the traffic capacities. You may refer to this slide for the capacity check. Basically, you are comparing the capacity against the traffic volume at the end of the design period. And we are talking about the daily capacity for both volume and the capacity. Now, the daily capacity representing 24 hours, it will be considered as 10 times of the maximum hourly capacity. Therefore, we will need to first determine the maximum hourly capacity. There are three components here. First, the I here represents the maximum hourly capacity under ideal conditions. That means one single directions, it will be 1000 passenger vehicles unit per hour. That gives you I equals to 1000. The other two components here are the reduction factors. The reduction factors are deals with the width of the carriageway as well as the road shoulders. Assuming the width of the carriageway is 7.5 meter and the width of the road shoulders is more than 2 meter, you may refer to the table here. 7.5 meters, 2 meters with the reduction factors of 1.0. That gives you 1.0 R. Next, it will be the traffic reduction factor T, deals with the T rank. It is given that the T rank is rolling. The T factors is calculated using this equation. PC is given as 15%. Substitute into the equations, you get the T equals to 0.769. Multiply I, R and T, you get the maximum hourly capacity, 769 vehicles. To get the full day maximum traffic capacity, the C here needs to be multiplied by 10 as given by the equation here. That gives you 7690 vehicles per day. This is about the capacity here. Next, you will need to determine the traffic volume at the end of the design period. You have the ADT representing the average daily traffic at the initial stage when the road is first being put into utilizations. It represents both directions. That means the ADT 6,600 vehicles are for both directions. Divided by 2, that gives you 3,300 vehicles per day in one directions. Next, you will need to estimate the daily traffic after 10 years. Based on the initial traffic volume, taking into considerations of the growth factors as well as the design period of 10 years, the estimated daily traffic after 10 years shall be equals to 6,492. Compare the traffic volume with the traffic capacity that we calculated previously. The capacity is greater than the traffic volume after 10 years. Therefore, you know that the capacity is not exceeded within the design period. With that, this is the work example demonstrated by the Arahan technique for the thickness design. In the work example, there were several trials in order to get the TA more than 26. The first trial does not acquire TA equals to 26. Then it followed up with the second trial and eventually managed to get the TA equals to 26. Ultimately, the proposed thickness of road layers are given here.